All right, good evening. Welcome back to Pre-Calculus. So we are getting to the second half of 8.3 partial fractions. Now we get to solve them, okay, rather than just set them up. So that's okay. So what we have here is we have 13x plus 13. Okay, so let's go ahead and say 13x plus 31 rather, divided by, we have x minus 3. At least they don't make us factor it, right? 3x plus 5. All right. And what we have to do is we have to set this up first. So we're going to set this up. We've got two linear terms here, right? Two factors. So that's going to say an a over a x minus 3 plus a b over a 3x plus 5, okay? And now we're going to solve this. We're going to solve for a and b here. Okay, that's our next step. So we have a rational equation. And how do you solve a rational equation? And the first thing you do to solve a rational equation is you make it something that is not a rational equation. So what I'm going to do is I'm going to multiply both sides of the equation here by 3x plus 5. Okay, this whole denominator. So as this whole denominator visits, okay, what's going to happen on my right-hand side is we're going to have a 13x plus 31. Okay, both of these factors are going to cancel when I multiply that through. Now, when it goes over and gets to visit the a part here, right, we're going to have a. Do you see that the x minus 3's are going to cancel? What are we going to be left with? We're going to have a 3x plus 5. Okay, plus, and we have to distribute this to every term in the equation. Okay, so what's going to happen as it visits this next piece, okay, the b's are going to, the 3x plus 5's are going to cancel, so we're going to end up with a b, and we have an x minus 3, okay? This is why I wrote it on the right-hand side, is so that when I go ahead and do this, we have 3ax plus 5a plus bx minus 3b is equal to 13x plus 31, okay? So all we did was make this into a set of, we just made this into a rational equation rather than having, we made this into a linear equation rather than having rational equations. And all we did was multiply by the common denominator. Now, I'm going to go ahead and say, you know what? If I add up all of the coefficients with x's in them, they should add up to 13. So if I set up, this is called equating the coefficients, okay? So this technique is called equate the coefficients. Okay, so we're going to say that 3a plus b, that's got to equal the stuff that's in front of the x. Okay, for my constant term, we're going to have 5a's minus 3b's is equal to 31. Okay, hey, look at that. We've got two equations with two unknowns in them. We've practiced that. That's why this section is in here. So why don't we go ahead and multiply this whole equation by 3, okay? So that's going to be 9a, okay, plus 3b is equal to 39, okay? And then I have 5a minus 3b is equal to 31. I'm just going to add those equations up, all right? So 9 and 5 would make 14 a's. The b's are going to cancel. This is equal to 3 and 3 is 6. 9 and 1 makes 1, makes 10, so we end up with a 70. So we have a is equal to 70 over 14, which I believe is 5. Okay, so that's our a. Okay, now we're going to say this is 3 times 5, just found that, plus b, we don't know what b is yet, is equal to 13. So 15 plus b is equal to 13. I think it's safe to say that b is equal to a minus 2. Okay, so we have a is equal to 5, and b is equal to minus 2. Okay, so we're going to go back up here. We're going to say, okay, how did I break this apart? So we have a is equal to a over x minus 3. So we have 5 over x minus 3 plus, and then b was minus 2. Actually, I'm going to rewrite this a little bit. I'm going to say, you know what, that's going to be minus 2. So we could rewrite this a little bit. Let's say this is going to be minus 2 over, okay, and then we have a 3x plus 5. Right? So we started off with a problem that this would be a little difficult to do in calculus. Okay, we'd hope that something substituted somewhere that would be nice and neat, but this 13 and 31 is not giving me very much hope that that would be the case. So we break this apart, and now in calculus, you're going to have two relatively easy problems to solve. Okay, these two problems in calculus are very easy. Okay, looking at it from the beginning, not so easy. Okay, so that's why you're doing this, is because later on you're going to be confronted with a problem like this, and it's going to be up to you to say, well, how do I solve this? How do I make this an easier deal? So we're going to do this, okay, and I'm going to say minus with the fractionary. Let's see if it lets us get away with this. So we're going to say 5 over, and we have x minus 3, and then we have a minus sign there, and we're going to say 2, and we have a 3x, 3, oh, there's x, plus 5. Okay, so also very useful for differential equations when you get there. This is used pretty often. So this is a whole section out of Calc 2. So hopefully you guys will practice this and it'll stick, okay? And the more you practice, the better chance it has of sticking. So don't just watch me do it. It has to come out of your pencil, all right? So we'll do the check. We got a green flag, and we go on to the next problem, okay? So good luck. Try these and practice them. This is actually a skill that you'll use in the future. About a year, but you'll start going to use it. Okay, I'll see you in the next video. Thank you.